You can't. No, I know, Nathan. But you can't name this tune. Sure, I can. It's Fred. Oh, I guess you can name it whatever you want. Yeah. Fair enough. Don't ask me to handle the same thing. Yeah.
Well, I see my co-chair is online, and we've got a scribe, and it's 4:30. And this, I think, is the last session of the day. So this is between you and a glass of wine. So keep that in mind in how we ask questions and how we have conversations. Priorities. Okay, so let's get started. Hello, I'm Glenn Dean. I'm one of your co-chairs. This is the ADD session. And all right. So please be advised, this is an IETF session, working group session, which of course is covered by NoteWell, which covers both how we treat each other with respect and kindness, as well as copyright and patents and IP rights. These are some tips for a meeting at IETF116. If you don't know them by now, then where have you been all week? Some resources for Yokohama. And I'm Glenn Dean, one of your co-chairs. David Lawrence is my other co-chair who's online. David, you want to make a comment? Maybe not. We, of course, are supported by our wonderful area director, Eric Vink. Yes, go ahead, Tail.
It was just a lag. All I did was say, yes, hi, remote from Vermont, 3:30 in the morning here. Sorry I couldn't be there.
So here's our agenda for today. It's actually a pretty clean and short agenda. So we've already covered the scribe. Is there any additions to the agenda, any new items people want to put on? Okay. I've already asked Eric, did he have any comments? And Eric already said, no, he didn't. Or do you have comments? Oh, he does have a comment. Okay.
So Eric Ving, the AD for ADD, amazing. Just to summarize the next point, right? You know that 3 documents were stuck in the queue because we were waiting for DNSOP documents that were waiting for encrypted ECH and encrypted SNI. With the help of DNSOPs and Ren Kumari, we basically removed part of it. So we need to redo all the working group last call. That's your next point. And basically to release all those documents of this situation that was blocked since last August. So thanks for all.
So on that point, the group has 2 documents out currently for a working group last call. They've been out there, they closed last week, and the chairs would like to announce that both of them we have evaluated as having passed working group last call, and we'll move them on to the ISG for the next step. We will be issuing a working group, a new call for the Split Horizon document. And also we were advised and suggested that we should also send that over to the DHCWG group for it to have a look-see because it does touch some stuff in there. So that call will be issued if I get around to either today or tomorrow before we get out of here, everybody travel home. So with that, we have 3 drafts that we're going to discuss today. We're going to get a quick update on what was changed in the Split Horizon DNS configuration document. Tiro, where's Tiro? Is he here? Oh, there he is. Come on up to the mic, sir. You're up. Let me bring your document up. And just let me know when you want
that. Yeah. Yeah. Next slide. Yes, so this was the main change that was done as part of this was to address the feedback that we got from Paul, right, with regard to the use of authorized claims that we had and some of the challenges with regard to validating whether these subdomains were indeed owned by the enterprise network or the network which owns authority over the domains. So to address that problem, right, if you see, we have introduced new attributes, especially which includes the resolver name, the parent name, and the subdomains that it owns, and an algorithm and a salt basically which proves which is used to create an attestation token which will be published as part of the parent domain. So on the right side, if you see, it's we have the uh, subdomain with the split DNS hyphen challenge, which is the keyword, and then followed by the parent domain. And the token is having the SHA of the SHA-384 of the salt, which is being generated. And then we had added DNS support, DNSX support for that as well. So I think this should address all the comments that we have received so far. I see Michael has raised few comments with regard to hash agility and probably one or two comments which should be easily addressable. I think we should be able to address all of them in the next revision.
Next slide.
I think that's about it.
One slide. I love those. Okay. Any questions, comments? Anybody want to come up with you? Ben
Finally,
Schwartz?
Ben has joined. I thought he would be presenting this one. So
Ben, go ahead.
Thanks for presenting, Euro.
yeah, I didn't realize I would be presenting this one. So
We only had 5 minutes, so we kept it very brief. The only thing I would say here is, this is a fresh design. Essentially, the non-technical components of this draft have not really changed, but the technical components are completely new. So I really would. I'm really grateful to the people who have given us already a lot of deep review and feedback. But definitely, if you're interested in this topic, give the draft another look. And the one thing that I want to highlight as sort of an open question is whether we should take this claim structure here, which is being represented as JSON for provisioning domains, or we have essentially a compact binary format for DHCP, whether we should move this information through those channels, which to me resembles DNR, where we convey information through DHCP, or whether we should actually be moving that information through a special record on resolver.arpa, like DDR. So this is a DNR style versus DDR style. So I would appreciate input maybe offline on that topic.
Tommy Polly Apple. Yeah, so thank you for that. And I think that's an interesting discussion, Ben. So let's have that on the list. So I want to dig in more to this in review and et cetera, but I think it sounds like a very good direction. What I was coming to ask is, could we get some like test vectors or example that would help, like when we try to implement and play with things, since this is, somewhat novel, we want to make sure that, particularly with these structures that have particular lengths, having done similar things with privacy pass tokens and stuff and structures, there can be a lot of just mistakes in implementations by not reading carefully how long fields are supposed to be and how things are supposed to be hashed, et cetera. So some test vectors at the end would be really, really helpful.
that should be possible. Yeah.
Okay, Tim, remotely, go ahead.
To follow up on Tommy, I remember hassling the Service B authors to do that same thing about test vectors, both good and bad, to help basically implementers try to understand what's going on there. So I totally go, yes, Tommy, good point. Thank you, sir.
Okay, any other comments, either online or in person? All right. Thank you, Tira.
Thanks.
Hey, I want to inject one more thing, which is that part of this slide mentions how we're proposing to enable DNSSEC in this particular special, very special way, where there's where the local resolver can hold a key that's associated with its role as a resolver that cannot be used to impersonate anything in the zone under other conditions. I think, you know, I wrote this text and I have some questions about how it works. I would really love some input from folks who have a deep understanding of DNSSEC and an open mind about making some interesting changes to it, about whether this can work as specified. I think it can, but I'd like to get some more input.
Okay. Thanks, Ben. And Tira, don't go away. I think you got another slide to talk about.
Yeah.
So the next in the agenda is the DNS resolver info.
Yeah, this is just a bunch of updates that we did as part of addressing the comments during the working group adoption call. Next slide. Yeah, the majorly we got 2 comments on this. One is to make the QNAME min and URL info as optional attribute, and the other one was to update URL info. I think we have taken care of that. Next slide.
Okay, so just speak up a little bit if for people remote. I'm not sure they're able to hear if you.
Okay. Yeah. One of the comments that we got was the URL info attribute was supposed to be only used for diagnostic information. So we changed that to be should, making it more normative, and to display that only in exceptional cases if the encrypted resolver has a sufficient reputation. So those were the 2 changes that we did to the draft. Next slide. Yeah, I mean, this draft is defining the basic structural attributes that the working group has agreed. We could add new attributes, but we have added also the registration policy, which is specification required to add new more attributes. If there are any objections to the current policy, if you believe new attributes to be added, you're welcome to that discussion. I don't think we don't have any further updates to the draft, so I think we can call for any new attributes to be added, and if none, then we can ask for a DNS directory review and then head for a working group last call.
Okay, and that's it. Any comments either in person or online for this draft? Okay, thank you, Tira.
Thanks.
And our last draft. Oh, sorry. Who's in the queue? Tommy Jensen. Oh, no, Tim, go ahead, please. You had a comment?
It was more of a question about anybody who's done some implementation on this, out of curiosity. Do you know of any folks kind of doing?
Not that I'm aware of.
Okay. That was kind of what I was curious about. Thank you. That's all.
Yeah, thanks.
Okay, thank you. And our last draft of the day. We are making great progress. So this next draft is an extended talk because it's fairly new. We've talked about it previously at the earlier prior ADD session, but I think the authors have made some extensive work. Right, Tommy? And so Tommy Jensen from Microsoft is going to present. Tommy, the slides are up and ready for you.
Awesome. Can you hear me?
We can.
Oh, sweet. Okay. So as you can see on the slide, John and I welcome a new co-author to the draft, Corey, also from Quad 9. Next slide, please. So we made a number of changes from IETF 115. The rest of the slides will walk through a bit more depth in the feedback. And then at the end, before we open the queue, we'll address a couple of items that came up on the list after these slides were submitted. Here you see the new text changed the name used to query for the redirection record away from the SUDN that DDR used to the name of the resolver itself. There's still some open discussion on that, but that's the current state of the text. We added some guidance on how to handle a multitude of edge cases, redirection chains, multiple redirects. We defined how to determine the effective TTL of a redirection, which really comes down to the minimum along the path that you travel. Added TLS minimum version as one example of a compat requirement. So we had always required that if you're a DO server redirecting to another server, it needs to at least support DO or whatever else the client currently had, so that you don't send them somewhere they may not be compatible with. TLS minimum version, same thing. If the client connected over TLS 1.2, it ought to be able to support TLS 1.2. And then clarified that we have no opinions or business. The client uses its own policy decisions on if it trusts a cert in other cases. If it trusts one here, that's its decision. Next slide. So numerous people pointed out to us that reusing this SUDN is problematic. And the two most common arguments we saw were that this would force resolvers to store their DDR configuration and their EDSR in the same zone, which is kind of painful, and that naive resolvers can pass this query upstream. And that's the thing that we're still open on. So I'll address that again at the end of the deck. Next slide. So generally, it's not a good idea to go creating redirection loops or redirect a lot. Novel concept. We added some text to elaborate on that. Self-redirection was defined as based on name. So if you refer to yourself in the same name as the connection, that's a self-redirection, and we're done. Again, Ben pointed out on the list that we can get the best of both worlds if we just say you can redirect to another IP of the same name if the server provides a set of IPs that don't include the one that the client's currently communicating on. This seems reasonable, but this is the current state of the text. So, but I think that's reasonable. Next slide, please. Oh, and one point I did forget on that one is when you self-advertise, you could also advertise more config that the client may not know about. So comparison with HTTP redirects and alt service work going on elsewhere. So alt service B, which actually was just mentioned a couple of minutes ago, focuses on pre-connection time, a query time, what a name's properties are, whereas this is definitely associated with a connection because the server wants to see the client before making that decision. Oh, they're coming from the wrong continent, oh, whatever else. And so we do feel confident that putting this somehow oriented to the connection is the right approach, and having the ability to redirect the connection as opposed to the requests also makes sense. Next slide, please.
Okay, and Mike Bishop just joined the queue. Mike, do you have a comment or a question?
Hey, Mike Bishop. I just wanted to distinguish that the service B records are for pre-connection. The alt service header and alt service B as its successor are for post-connection. Oh, now that I see you, I would actually like you over here.
Right. No, that's a good distinguisher. So, and then the header, of course, brings us into that scenario of, well, now we're talking DO specific, and we want to address the problem for all TLS-based encrypted DNS protocols. But yes, you're absolutely right. Two different forms of alt service. Thank you.
And Ben Schwartz just joined the queue. Ben, go ahead.
Sorry, Glenn, I can barely hear you. Are you?
I'll take my. Hey, sorry, I turned my mic off. I did a bad thing. I turned my mic off over here. Yeah, Ben Schwartz just joined the queue. Ben, do you have a comment for you want to share?
Hi, can we go back to slide 5? The last sentence on this slide I find very confusing.
We're going to talk about that here in a second.
Okay.
Okay. So the final slide here, a couple of items that were brought up that did not result in text changes. We believe this is actually something that can help with geo-based policy concerns. If you're deploying Anycast today and you want to see where your traffic is going, you see the one IP address. And this scenario where a resolver can redirect a client to a specific resolver, you can actually see that change and have some transparency as to where your requests are going, as an example. And this is not intended to replace client config, as stated at the last meeting. Although you can obviously see how someone would try to use it to do so. So Ben, there's a slew of things, but the first two very obvious ones that we've been discussing since your last email chain. One, abuse of the target name. You're absolutely right, which shouldn't surprise me at this point. We're discussing some other options about how to communicate a name we want to move to, but that's a technical problem that hinges on the bigger issue, which I think is where you're headed, which is why are we redirecting to other names in the first place? And the primary scenario that we've been discussing, and I welcome my co-authors to speak up if other details come up, but in a scenario where you're using this to replace Anycast, you would want the server that you're configuring widely to have access to a key that you may not want all of your distributed servers to have. That way, if they each have their own keys, if one is compromised, it can be revoked, redirections can be revoked, but the main server is not compromised. Containerized, which means that we need to find a way somehow to allow one server to redirect to another where the name ends up changing. Target name is not the right field to do that. That's fair. And for your concerns on the naive resolver, as you pointed out, just changing the name to the name of the resolver does not guarantee that an EDSR naive resolver will end up intercepting a query for its own name. It can still send it upstream. We've been talking through how to solve that, and this is definitely where we'll go open queue for ideas, but a couple we've been thinking about include having shared certs between the servers, which has its own limitations, or having the client do something like full DNSSEC validation of these redirection records, which as a sub-resolver has its own costs, but is a potential solution. So with that said, fire away.
Ben Schwartz, go ahead.
Hi. So yeah, I want to say I understand and appreciate the idea of having a potentially high value global certificate that you don't necessarily want to plant private keys for inside all of the various geospecific servers that you're trying to redirect to. You know, that seems like certainly an understandable desire here. I was specifically talking about on slide 5. It seemed like there was a sort of factual question that I think gets to the core of this particular little debate.
Sure.
Because it mentions HTTP alt service as precedent for the idea of redirecting and accepting the redirect based on the transport security of the connection over which the redirect information was given. But that's actually not how HTTP alt service works. HTTP alt service does the thing that I've been talking about, where the new host still has to present the certificate for the original name. And there is no trust placed in the alt service record, even though it was delivered over an authenticated connection. So
That's interesting.
as this is not a we don't have to do things the same way that HTTP does things.
Okay.
But the analogy doesn't work in quite the way I think that slide wants it to.
That's interesting. I have run across some uncompliant deployments then in some surveys, so that's good to know. Okay, noted. So then how do you feel about the approach going forward then, slideware aside?
Yeah, so overall my view is that there's kind of a simple, safe thing to do, which is to just not change the authentication name and require all instances of the service to prove the same identity. And to me, it seems like we ought to solve that case because its security properties are a lot simpler and clearer. And then if we still need this, if we still need this sort of more aggressive mobility where we need the ability to redirect users to some other service that is, for TLS purposes, not the same service as the one you started with, then we can sort of come back to the design and think harder about the security implications of that. That would be, to me, sort of the easiest way to do this, because there are other alternatives, right? Like there are a lot of systems out there that backhaul the handshake to a secure data center. So maybe you have a box that you don't want to be holding the private keys for some name, but that's okay. It can still terminate those connections by holding just the TLS session keys for those sessions, while the private keys for that certificate are held in a data center. That adds a little bit of latency to the handshake, but then the rest of the connections are fast and local. So there are lots of different architectures that we can talk about to solve the sort of more aggressive redirection problem.
That's a good example. Sorry, go ahead.
Can I throw a few cents in here? This is John Todd. So I think one of our goals with this initially and the contemplation of it is the ability to distribute, again, within a trusted sphere, distribute the work of the task. We know we've seen in conversations, although I can't put words in the mouth of anybody implementing this, but in places like DNS for EU, where there's an interest in how is the regional trust model created, or at least that was in the part of the initial conversations. Whether they go with it or not, I don't know. But where one company can actually redirect inside to another company by basically choosing a redirection. The model initially was considering how do you do shared anycast. That's a really terrible model. So this seems to solve that, or make this possible to solve, both inside an organization where you have different security models and different namespaces, but also between organizations where you're definitely going to have different certs, and or it's going to be impossible to share cert data, but it is possible to do redirection. So I agree with you that the simplest way to do this would be to have shared identity across all instances. And maybe that's something we have to think about, is maybe there are two different models here. There's the simplistic model where we have a shared identity, and then there's a second or a different version of this which allows transfer across domains or across certs in some fashion. So that's definitely worth thinking about. But the hope is, again, to decentralize things a little bit more than they have been. That's what my comment was.
Okay, Tim, next in the queue.
Yes, Ben, from what I gather, I'm thinking when you start up, you would go to the central place to get that main private key, and then you would probably fetch it every so often on some TTL or something. Is that how you're seeing that?
So
that doesn't make sense.
I'm talking specifically about systems where you do where the private key for the server's private key for TLS never leaves some secure facility, which is not the same facility where TLS is being terminated.
Yes.
So the handshake is the Diffie-Hellman handshake happens to some central facility. A session key, Diffie-Hellman output is generated, and that is moved to the box that's terminating the session. That, I think, is not helpful for the problem space that Corey, I think, was just telling us about. So I just want us to think about the broader picture here. One thing that seems like another sort of category of architectures to consider is like maybe these really are separate problems, and maybe this question of having lots of different logical services that you're connecting to, maybe that actually looks more like a different ADD charter item, where we've talked about resolver selection, providing information to the user so that they can choose between different resolvers. So I think it might be helpful to draw a clearer line between the thing that is analogous to an HTTP 300 redirect and the thing that is analogous to HTTP alt service.
Yes, and I kind of see it as something that maybe it happens like initially, like you said, but then every so often in some TTL cycle, right, it generates a new key and sends it along to the remote servers kind of thing, right? That does make sense. Okay.
That would be driven by the TLS session ticket lifetime.
Yep, perfect. Thank you.
Okay, thanks, Tim. Corey? Can't hear you, Corey.
I thought the video would unmute at the same time. So a couple of things. We've discussed a number of different possible approaches internally on how we could address this, and driven by real life examples. Number one is obviously, the Akamai model, where you're okay sharing your certificate to maybe large scale infrastructure that's present in protected environments. But the problem is when you do cross into those unprotected geopolitical danger zones, where you do not want to share your certificates. The problem is that if we were to trim the redirection cycle to essentially a single redirect or an in-bailiwick redirect, we're unable to then essentially move towards these local, more unprotected geos. Where at some point we're still being forced to essentially share these certificates. There are a couple of different approaches we can take here, and one of the ones we've talked about internally is essentially forcing a redirection chain to follow the TLS certificate chain model. So for instance, server one, the very first server you're talking to, is going to have a certificate, in this case dns.quad9.net. Server two then also has to have dns.quad9.net, which follows the same logic as the is required inside of the service B approach. But then what we would do is we could potentially say server two and then server three, being the final redirect, the final intended server, would actually then share a certificate. So the certificate on server one would be present on server one and server two. The certificate for server two would be present on server two and server three. And therefore we've maintained an unbroken chain of TLS authorized, right, certificate authority authorized servers in order to ensure that there is an unbroken chain of trust between these systems. So you're never just being redirected off into the wilderness. You're not being sent to some random third party. Is that relatively clear? That's one of the things we've talked about. We have two other models that we've been discussing involving DNSSEC validation and remaining in bailiwick and a few other things, but I don't think we're quite ready to talk about those.
Okay, thank you, Corey. Eric?
Eric with Google. I want to pile on to the hesitance on anything that does redirection of the auth origin for this, because thinking through Chrome, there's very little that changes such things. It's basically HTTP 300 redirects is the one thing where we'll really change the auth origin. And it's a very scary thing to tool, and a lot of security people are concerned about making sure everything's just right to not mess it up. But everything else that does redirection that is the primary security mechanism that keeps everything safe, is you just do not change the auth origin once you've picked the domain that you want to connect to. So if at all possible, I'd say find a way to not change that origin and only stick to redirects that keep the origin the same. If that's hard, yeah, we got to figure out hard ways to make that work, because that is the easy route to keep things secure. And with security, you want to keep things easy.
Thank you. And the next Eric. Ecker, you're in the queue.
Are we next? Oh, okay.
Yeah, I guess I'm also feeling somewhat uncomfortable with this. And I guess I'm not sure I'm not sure how much I think the threat model feels well understood. So, these servers, which are these servers are located in some data center, which you feel like have limited control over, and you're worried about compromise by hypothesis. Otherwise, you wouldn't share the regular certificate, right? That's like the setting. That's like the regular private key. That's like the setting we're talking about, right? That was a question.
I didn't quite get it.
So the setting of concern here is that you wish to, is that, I was configured with ns.quad9.com, and you want to bounce me to some other server, which is located in some facility, which you're sad about, which you're don't really trust. And so you don't really want it to have the same certificate as ns.quad9.com. That's like the same private key. That's the underlying threat model, right?
That's one of them, yes.
So I mean, this is what delegated credentials was built for. It's exactly this use case. I think whether that's still like a valid design situation, but that's what DC was built for. Was so that you could do this and have a short-lived delegation and can revoke it quickly, basically, right?
Okay.
I mean,
from the security components are certainly, or how do you share the certificates is, I think, a core component of the reason. But being able to share across domains is also, there are also policy reasons for that as well, which are separate from what we're talking about as far as some of the issues underlying cert sharing.
I'm not sure I follow share across domains. Go ahead.
Sorry?
I'm not sure I follow share across domains.
So as an example, it might be the case that you wish to actually transfer this resolution to, if you're, as an example, inside of a large corporation, there's a single name that everyone in the corporation uses to find essentially a rendezvous server. They connect to that. The first time they do their resolution, they are redirected, or they create a redirection policy, which then redirects them to the policy resolver inside their own department. So that may be a different domain space. In other words, it would be engineering.foo.com. So there's both the reason to distribute or have certs isolated, but also there may be a reason to actually change the resolver based on policy that is top down, meaning that the top level or the first resolver in the chain trusts wherever it's redirecting the end user to, but there's a slightly different policy in place. But again, the chain of trust is not broken because you've got resolver A has to actually believe and understand what the policy is of resolver B in order to do the redirection. But I understand your perspective on cert and distributed, or the
sure. I guess I have to think more about your sort of chaining architecture of overlapping the certs, but I'm not sure that does what you think it does. So maybe if do you have the document where it's been written down? Because maybe that would be something we read and reason about. Because we had this thing, we were it's A and then AB and then B, right? Was how I thought I heard you describe it.
That's one possible way of doing it. Yeah.
Yeah. Has that been written down somewhere? Is that in this document? I'm sorry if I.
Not yet. It's not in this version. No.
Okay. Well, I think it'd be worth writing that down because I think and trying to read. So I'm not sure I follow what the sort of security reasoning is there.
Okay.
Okay. And before Tim goes, I want to be. We're gonna do a poll. Once this discussion is done. So if you're in the room, could you please join with the local queue stuff so that you'll be able to participate in the poll? And if I could make an observation here and suggestion, it sounds like we need some of Ben Schwartz's famous, beautiful diagrams to explain this situation. So I don't know, Ben, if you want to contribute some of these fancy diagrams to this chaining idea. You came through for us before with some just beautiful diagrams that broke through the logjam of discussion. So just a suggestion. And okay. And with that, Tim dropped out. So Ben, I guess you're up. Ecker, are you trying to be back?
That's very nice. I just want to check that I understood something previously that I guess John said in the context of DNS for EU, that one of the use cases here is about essentially federated deployments where there really is no hierarchical relationship between the redirect source and the redirect destination. And I am saying I'm provider one, but actually given the metadata or whatever of this connection, you should just go talk to provider two. Provider two, to trust me, provider two is a good resolver also. go use them.
That is a
Is that
possible outcome. Yeah. And by the way, I said I'm putting words in the DNS for EU folks' mouths.
okay?
When that was initially a proposal, when it was very early on, we kicked around a whole bunch of ideas about how to distribute queries or how a centralized name would actually redirect into much more regional resolver clusters that had policies that were trusted but maybe different from that of the central one.
Okay, thanks.
Okay, and with that, are there any other queues, either remote or in the room, that would like to make a comment on this draft? Okay, thank you, Tommy. So my co-chair and I, Tail, who's online, we've been exchanging notes here, and we want to sort of take a non-binding sort of survey of the room. So I'm going to put it up on whether we should consider adopting this draft as a working group draft for the ADD group. And so there it is. So raise your hand if you think we should consider adopting it, and do not raise your hand if you consider we shouldn't be adopting this as a working group draft. And while you're all doing that, this is the trick working group chairs can do to get the people in the room to do their blue sheet, because you have to log in to do this. So do a poll every meeting, and you get the blue sheets taken care of. Do nothing. We're taking a general sense. This is not binding. This is just to gather a sense in the room. Okay, so I think we're sort of done there. So what I'm pulling out from in a non-binding way, not counting the no responses as a no's, but 26 people did think that we in fact should probably go ahead and adopt this as a working group draft. And 10 people deliberately did not raise their hand, which we might be able to count as a no. Okay, and with that, that's good results. And I think we are, once I pull up the final slides to make it official. How do I get rid of that? All right, there we go. And back to the slides. Okay, let's see, we're at the, oh, it'd be nice. So it would be really cool if this thing remembered where we last showed. There, it's official. It's the end. Thursday's ended. If you're going to the social, have a great time. If you're not going to the social, still have a great time. We'll see you in the next IETF for ADD. Bye-bye.
Again to our note
and
takers.
thank you for our, go ahead, Tail.
I was just saying thank you again to our note takers.
Which is what I was going to say. Yes, thank you, Tim and Limon, for our note taking. Thank you. That means you could leave.
I literally typed this wrong. We have time.
Yeah.
reference was bare metal, which